Hi, this video is to talk about hypothesis test for difference in means of two populations when I know the population standard deviation. This is chapter 10. This is hypothesis test is different than confidence interval or interval estimate. Okay. So what we are doing in this video in this topic, again, we don't know how two population means differ, and we'll test hypotheses about the mean difference in these two populations. We don't know the population, then we're going to use sample data. We're going to establish a confidence level based on our own criteria and then find z-scores to come up with the hypothesis test. So let's understand hypothesis test. And to understand hypothesis test, I have to recall the normal distribution. Remember that a sample mean, denoted by x bar, is a point estimate for the population mean mu. This population mean mu we don't know, so it's a simple mean x bar. If the simple mean x bar is large, which means has a sample size higher than 30, it has an approximately a normal distribution, And if we have two sample means, x bar 1 and x bar 2, coming from large samples, then we can view them as point estimators for the two populations. And then if we subtract one from the other, which means we are taking their differences, we can estimate these differences as the population mean differences for mu1 and mu2. Okay? Because they're both normally distributed, we can estimate their difference as z-scores normally distributed. Let's take a look at that. That's a lot of theory. I don't want to get you confused. So what we're really doing is we are getting the difference between two samples. So I collect two samples. One sample, let's say students from the College of Charleston and students from, I don't know, University of South Carolina, and they have their GPAs and the mean GPAs for each one of the samples. And then this is the difference. So I'm going to standardize into a z-score. Remember, z-score is the score in standard deviations from the mean. So I'm going to compute this and see how much this difference is from the mean. In this case, we have another term here, which is the hypothesized difference. This hypothesized difference for this class will always be 0. This is here just for you to understand that we're comparing a difference between two populations using samples and comparing to a hypothesized difference. In our case, this is always 0. We always cross this, so the final formula is only the difference between the two sample means, okay? And then after taking these differences, we divide by the standard deviation for these two populations. And that results in a standardized z-score that represents this difference. I hope I don't make it too confused, okay? Let's take a look at one example. We have training centers, okay? And a standardized examination was given to individuals who are trained at the two different centers to evaluate the difference in education quality between these two training centers. So we have mu1, which is the mean examination score for the population of all students trained at Center A, and mu2, the score for the population of all individuals trained at Center B. Let's assume we don't know what this means, okay? And then we collect a sample, which has 30 students from Center A, 40 students from Center B. We compute their mean scores, 82 and 78, and we know their standard deviation. Remember, this is the case where I know the population standard deviation, which is 10 and 10. So we see that the score is 82 and 78. They are different. They're not the same, okay? But because we are using a limited sample for both cases, these differences may be due to a sampling error. I selected simply students that vary or because they're not exactly the same, and I cannot conclude that they're really different because the sample is limited. Okay, so are these two training centers composed of different populations, or are they the same population since they're from the same company? If you compute their differences, 82 and 78, how much they deviate from the expected mean of 0? If they're really equal, so if the training centers have the same quality, the scores should be the same. So I would have 82 and 82, or 78 and 78 in both. The resulting meaning would be 0. No difference between the training centers. In this case, we have a difference. So how we're going to compute a z-score for this difference and see how much it deviates from 0. Remember, 0 is the mean for a standardized distribution, or z-score of 0. Okay, so what's the z-score in this case? We could compute that. So that's the idea. You compute the z-score, and then we're going to use a procedure to test hypothesis. Okay. But before we talk about the procedures, let me show you how the hypotheses look like. Okay, so we can have a difference between two population means that are higher or equal than a hypothesized value. This hypothesized value is always 0. Okay, we can have the differences in the population means be smaller than 0, or we can have the difference equal to 0 or different than 0. Okay, so let me show you that in before I show you, let me show this case is the lower tail case, this is the upper tail case, and this is the two tail case. Okay, so let me show you something here. So remember, let me draw. I have the lower tail case. I have that mu1, the difference between the means is higher or equal than 0, and the alternative is that the difference in them is smaller than 0. So for this case, we have that the difference should be in this side. This is lower, okay, which represents this one. And that's a lower tail test when I have a hypothesized case like this. I also can turn this hypothesis into mu1. If I move this mean to the other side, will be this mu1 higher or equal than mu2, and the alternative is that the mu1 is smaller than mu2. Okay, let me see if I can find one example like that in our book. Inferences, let me see this. We have building a confidence interval hypothesis test. Let's take a look at some applications so let me get a short problem. Let's use this one. US Today reports that the average expenditure of Valentine's Days is 189. So let me show you, let's take note about that. The mean is 189. Do male and female consumers differ in the amount they spend? So we have two populations. The average expenditure in a survey of 40 male consumers was 135.67. So the mean for males is 135.67. 135.67. Let's call, instead of male, let's call mu1. Okay, So mu1 and mu2 is the mean for females. The average expenditure in a sample survey of 40 male consumers was 135. So okay, I took note. I know the sample size. And the average expenditure in a sample survey of 30 female consumers was 68.64. Okay, so if I go back here, I have 68.64. I have a sample size 30 and 40. Okay, so the question here is, do male and female differ in the amount they spend? It's not saying that male consumption is higher, male spend more, or female spend more. It's simply they differ. Okay, so if I'm doing the hypothesis, let me go back to the slide so I can make a connection. Do you think that the hypothesis will be this type? Higher, lower, or will be this type, equal and different? Do they differ or not differ? Okay, so when you read a problem, you have to be able again to interpret which of these three types we are talking about, and this is given by the reading in the statement of the problem. So what is this point? The point estimate for the difference, develop a confidence interval, blah, blah, blah. So here we're talking about confidence interval, but could be a hypothesis, okay? So let's take a look at this one more. This one, I want to get one that is higher or lower to be able to show you. This one formulated, there is a difference between a population. If there is a difference, a two-tailed test. Let me see another one. Can you conclude? This one could help. I have only 2.5 minutes. So what this statement is talking about is that they have right 8 and other companies and score in year 1 and score in year 2. And I think that they want to know if the score in year 2 is higher than the score in year 1. So here it is. When conducting a hypothesis test with the values given for the standard deviation, sample size, and alpha, how large, blah, 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 no. Okay, here. Use the result from here to state whether the increase for J.C. Penney from year 1 to year 2 is statistically significant. So we have the word increase from year 1 to year 2. So let me go back here to show you. So I have, let me put here, I have mean 1, I have mean year 2. These means are for J.C. Penney 7778, 7778. The question is, I want to test, that's what I want to do, if there is an increase from year 1 to year 2. So I have year 1 and I can put here year 2. Is there an increase from year 1 to year 2? I want to test this. This is what I don't know. This is my alternative hypothesis. Okay? And this is obviously the opposite. So mu1 is higher or equal than mu2. And this is very similar to what I showed you here. Okay? So when you get this hypothesis, and then you turn into this model, which is moving one of the terms to the other side of the inequality, and then we have something like this. This is the case I just showed you, which comes from this problem here. I'm going to stop here and prepare another video to continue this discussion.